Hello, class. Our goal in this video is to do some more examples of u-substitution. So in the last video, we went over the overall process, and I described it as more or less a 5-step process to solve an antiderivative of this sort. So the first step in the process was to identify some sort of inside function and then call it u. So in this case, that inside function is going to be the 5x. So I'm going to write down u equals 5x. So that was our first step. Our next step was to calculate the derivative of that. So in this case, du, which is 5, and then we put a dx after it. And then we use these two together to translate the integral into something that only involves u and du and that no longer involves the x and the dx. So the first thing you see will be that, hey, I can replace this 5x with a u, because this statement here is saying that u and 5x are the same thing. But then I have a dx, but not a 5dx. So I want to make this a 5dx, but to do that, I have to multiply by a 1/5 out front. Or you could put the 1/5 inside the integral. It doesn't matter. Okay. I want to emphasize this step because this is something you're going to do a lot in various u-substitution questions. Namely, you're going to need a constant to go in front of the dx. And so whatever that constant is, you're going to multiply by it and also divide by it so that you haven't actually changed the thing that's going on. Okay. I'll note, because this is important, this only works because 5 is a constant. Okay, so don't try this if you need an x squared and you don't have an x squared. You can't just multiply by 1 over x squared outside of the integral. It won't work. Okay, but having done that, this turns into 1/5 the integral of secant squared of u du. Okay, and I've now completed my translation. And I know I've completed my translation because there's no longer any x's left in this thing that I'm looking at. This is just now framed to me in terms of u. So now I hope I can do the integral. And do I know the integral of secant squared? Well, I should know the integral of secant squared because secant squared is exactly the derivative of tangent. So this becomes 1/5 the tangent of u plus c. And I put the plus c just like always. No big surprises there. But now I have one last step, and that's that because I invented this u language for the purposes of this problem, I need to undo that piece of work. So I'll go back here and rewrite this as 1/5 times the tangent of 5x plus c. And so that will be my answer. Okay. Now, I'll note if you're at all concerned that you might have done something wrong, you can go back and you can take the derivative of this thing to make sure that you get what you're supposed to. So I'll do that just in this example. I'll take the derivative of 1/5 of tangent of 5x. So that's going to be a chain rule question. So the outside function here is going to be 1/5 times the tangent of x. The inside function will be 5x. So f prime of x will be 1/5 of secant squared of x. G prime of x will just be 5. And so if I took the derivative of 1/5 of the tangent of 5x, I would get f prime of g, which is 1/5 of secant squared of 5x times g prime, which is times 5. And if you look closely at that, you'll see that the 1/5 and the 5 cancel, and you get exactly secant squared of 5x, which is the thing we were supposed to get. Okay, so as a note, all of this down here, this is just me checking that we got the answer correct, that we really found a function at the end of the day whose derivative was secant squared of 5x. Okay. Let's do another example. Okay, let's find the integral of 2x plus 3 cubed dx. Okay. Now, this example, you might be inclined, and this would be perfectly okay, to rewrite this as 2x plus 3 times 2x plus 3 times 2x plus 3, and multiply it all out. And you know when you do that, you're going to get some term with an x cubed, someone with an x squared, someone with an x, and someone with no x. And you know how to integrate all of this with the power rule, so you could just do it. Okay. So I'm actually going to change this question a little bit. I'm going to make that 3 into an 8. So you could do the same thing. You could say, okay, well, this is 2x plus 3 times 2x plus 3 times 2x plus 3. But that's going to get awfully unpleasant to multiply out. And so what you can do is, instead of trying to multiply all of this out, we can use u-substitution. So we can notice, hey, there's a function here that's inside another function. Namely, there's this 2x plus 3 that's living inside of something raised to the 8th power. So I can write here u equals 2x plus 3. That's my inside function. So then I'll write down the du, which will be 2dx. And then I'll go ahead and translate everything here. So this will be the integral of u to the 8th. And then I'll go ahead and put a 2 in front of the dx. But remember, I have to pay for this 2 by putting a 1/2 out front. And so then this is 1/2 of the integral of u to the 8th du. Okay. And note, only at this point have I gotten rid of all of the x's. You cannot do the integral if the integral has both u's and x's. Okay, so that is important enough. I wrote it down. Okay, but here we're back to a situation where we have only u's, and so I can just do the integral using the power rule. And so then that is u to the 9th over 18 plus c. And then all I have to do is remember that I have to put back in what u was before I'm done. Namely, u was 2x plus 3. And so that winds up being our answer. Okay. Again, if you wanted, you could go back and check your answer. Make sure that if you take the derivative of this, you really get that. All right. I'll wrap up this video here, but we'll be back in the next video, and I'll do even more examples of u-substitution questions. But until next time, be well.